Let's talk about what continuity means. This is the definition of what it means for a function to be continuous at a point. It's phrased in terms of limits. This is what it means for a function to be continuous on an interval. Let's start by looking at what it means for a function to be continuous at a point. There's three things involved. The first thing is that this limit, as x approaches c of f of x, it has to exist. The second thing is that f of c has to exist. That is, c has to be in the domain of f. The third thing is that these two things have to be equal to each other. If these three things are true, the function is continuous at the point c. Let's try these out on an example. The example will be this piecewise function, and we'll consider it when c equals 1. The first thing is we have to look at the limit as x approaches 1 of f of x. Remember, when we take the limit as x approaches 1, we only consider the values of x not equal to 1. So that means that we take the limit as x approaches 1 of x plus 1. And to do that, we just substitute in 1. 1 plus 1 is equal to 2. The second thing is we have to look at the value of f of c. c is 1. F of 1 in this case, we follow this piece of the definition. F of 1 is 2. So f of 1 is equal to 2. The third piece is we check to see if these two are equal, and 2 is equal to 2. There's two 2's. That 2 is that 2, and that 2 is that 2, and 2 is equal to 2, so the function's continuous. Let's now look at the second part here in continuity on an interval. For that, let's use a graph. And this is a picture of a continuous function because it's continuous all across the interval. At every single point, it satisfies this. So no matter where we put a point c in this interval, it's going to satisfy this description. We can recognize it because it looks like a nice continuous graph. There's no breaks. One type of function that's continuous on any interval is a polynomial. We had already said that no matter what c is, for the polynomial p, the limit as x goes to c of p of x is equal to p of c. That'll be continuous on any interval that we pick. Polynomials will always be continuous. They'll even be continuous on the whole line. We should make a little footnote here about continuity on an interval, and that's what happens at these endpoints a and b. Limit as x goes to a from above, that is, as we come to a from this way, should be equal to f of a. That is, it has to be continuous as we come from above or come from the right at a. And similarly over here at b, as we come from the left, limit as x approaches b from below or from the left has to be equal to f of b. That's a basic description of what continuity at a point and continuity on an interval means.